Hi all, today we are going to discuss about mathematical models in the control systems. So coming to this mathematical models, any object or anything can be written in the form of an mathematical equation, right? So now here we are going to write the mathematical models for different types of systems. So, and here today we are going to talk about the translational model of a mechanical system. So actually when we talk about the mathematical models, we can write the mathematical models for different types of systems. We can write the mathematical models for mechanical systems, electrical systems, pneumatic systems, thermal systems, stochastic systems, and for the different types of systems we can write the mathematical models. And coming to the case of the mechanical systems especially, we can write the mathematical models by considering two types of models. So first one is mechanical translational system and second one is mechanical rotational system. So coming to the first case, the mechanical translational system, here the input what we are going to consider is in terms of force, which is a linear element, and coming to the elements what we are going to have in this translational system type of model was every mechanical system can be represented in three elements. So that is, first one is mass, second one is dashpot, third one is spring. When we want to represent this mass, so mass is actually represented as like this, and dashpot is going to be represented as piston element, and spring is going to be represented as like this. So this represents the weight of the system, and this represents the frictional property of the system, and spring represents the elastic property of the system. So now when we are going to have a pictorial representation of a mechanical system in translational model, we are going to now write the mathematical model for that type of system. So now here we are going to take an example and we are going to discuss about that. So for that I have chosen an example. So see here, so this is a mechanical system. So see how we have represented here a mass, and this represents the mass, and here this represents the dashpot, and here this represents the spring, right? So we have all the elements which are connected here, and this is the F is the force which is going to be applied onto this, and this representation is a rigid body representation, and when force was applied onto this, this will gives the displacement. That is, when we apply the force on a body, then the displacement at this element is going to be given by this element x1, and at the mass m2 is given by x2, right? So now for writing the mathematical model, so the process what we are going to follow was, the first thing what we are going to do was, we are going to represent the free body diagram for a given mechanical system. Free body diagram in the sense, so when we take this problem what they have given, so we have to represent individually the mass elements. The mass elements are going to be represented individually. So and here after this step, after representing that, second we need to write the force balance equations. We need to write the force balance equations. So coming to these force balance equations, these are going to be written such that we need to represent the forces, applied forces, and the counter forces which are going to be acted onto that given system. All the elements are going to be represented in a single equation is going to be called as an force balance equation. So after that we are going to represent a differential equation. We are going to represent in the form of a transfer function. So we need to represent a transfer function. So this transfer function will gives what is the actual mathematical model for a given system. So now coming to this problem, what we have taken, so the first thing what we are going to do was, we are going to draw the free body diagram for this given system. So the first step what we are going to choose was free body diagram. So see how we are going to draw the free body diagram for this. So for that, first I have taken this mass element. So see, for representing the free body diagram, we have to represent first the mass element like this, the mass m1, and first we have to represent what is the input force on this mass. If we have any input force, we are going to represent it. If not, we are not going to represent that. See here in the given question, we have an input force which is acting on it. So we are going to represent the force here. So and that input force is going to be represented here, F of t. And then if this force F of t is going to be applied on a mechanical system, then the elements which are present in the mechanical system will obviously apply the return force on it. So now we are going to write what are those forces which are going to be applied return onto this force F of t. So the first element what we need to represent was the opposing force acted by the mass m1, and then after, if you see that how many elements do we have connect for this m1, all those elements are going to be written here, right? So now for this m1, the first of all, the opposing force which is going to be applied onto the F of t was the mass itself. So we have represented Fm1, and coming to the next force, see here the dashpot B1 which is going to be connected between the mass and the rigid body directly. So we have to take that Fb1, and then after we have to check whether any element is connected between two mass elements. So now when we go with that, the B2 dashpot is connected between two mass elements m1 and m2. When you are going to have this type of situation, then we are going to write the equation such that the force which is going to be occurred is going to be represented with Fb2, and writing the equation we will see when we write the force balance equation. So now this is the first free body diagram for the mass m1 what we have represented. So now we are going to write the force balance equation here. So first coming to the force balance equation. The first force balance equation was given by first F of t, which is equal to Fm1 plus fb1 plus fb2. Right? So now how to replace the force m1? So m1 is going to be replaced with the element d square x1 of t by dt square m1 plus b1. It was connected individually between the mass m1 and the rigid body. So we are going to write this as b1 d x1 of t by dt plus b2, and this is the element which is connected between two elements, which is the mass m1 and m2. So we are going to write this as d by dt of x1 minus x2, and here we are going to apply, this was f of t, and now we are going to apply the Laplace transforms for this. So now if you apply the Laplace for this, it is going to be written as f of s is equal to m1. So this differential element is going to be converted into s. So as being this was square, so this was written as s square x1 of t, x1 of, so s t's terms can be represented in terms of s plus b1 s into x1 of s plus b2 s into x1 of s minus x2 of s. So now here we are going to write all the elements, that means we need to represent all x1 terms at one place and x2 terms at the another place. So now if you write that here, see here how can we represent that. So we are going to have here, so we can write here f of s is equal to, so we can take x1 of s common from that. So we can have here m1 s square plus b1 s plus b2 s into x1 of s minus b2 s into x2 of s. Right? So this is the equation what we have. So now we can take s also common from this. So m1 plus, we can m1 s square plus b1 plus b2 into s into x1 of s minus b2 s into x2 of s. So this was f of s is equal to, so we can represent this as an equation 1. So next we need to represent the free body diagram for the second mass. So now coming to the mass 2. So now coming to the mass 2. So mass 2 free body diagram is going to be represented as like this, m2, and see here we don't have any application of the force here. As when we go with the mass m1, we have the input force which is applied here, but we don't have any force applied here, right? So then we can simply represent here, we don't have any applied force here, right? So only we are going to have opposing forces which are going to act on it. So for this, the first element which is going to be was the mass itself, and second the dashpot which is between the mass m1 and m2, and third element which is the spring k. So now all the three elements are going to be represented as f m2, f b2 and f k. So now writing the force balance equation for this. So this force balance equation is going to be given by, we don't have any applied forces, so 0 is equal to f m2 next plus f b2 plus f k. So now we write the balance equation in terms of differential elements. So d square, here being it was mass m2, the displacement for this respective element was x2. So we are going to write this as x2 of t by dt square plus m2 d square x2 of t by dt square plus b2 into d by dt of x2 minus x1 plus k into x2 of t. So we have to note that while writing the dashpot B2, when we talk about the equation 1, we have represented the B2 between the displacements x1 and x2. But when we go with the case of this second mass, we have represented between the terms of x2 and x1. So we need to make sure that we have to be cautious when we write the equation. So now for this we are going to apply the Laplace transforms. So now when you apply the Laplace transforms, so 0 is equal to m2 s square x2 of s plus b2 s into x2 of s minus x1 of s plus k into x2 of s. So now same as in the case of the previous case, now here we are going to take x2 as common. So m2 s square plus b1 b2s plus k into x2 of s minus b2s into x1 of s is equal to 0. This will be the equation 2. So now here we have to write the transfer function element. So actually the transfer function is going to be given by Laplace transform of the output to the Laplace transform of the input. So now here the input was the force what we have here, which is f of s, and coming to the outputs, actually the outputs are two. One is x1 of t and second one is x2 of t. So that means when we have represented that in terms of the Laplace transform, one is x1 of s and another one is x2 of s, right? So now either we can write the equation with respect to x1 of s, which is given by x1 of s by f of s, or we can write the equation as x2 of s by f of s. We can write any of the elements according to the question what they have given. So here I want to write the equation as x1 of s by f of s. So now for this we have to bring the two equations 1 and 2 at one place. So now see here, so the f of s equation was given by m1 s square plus b1 plus b2 into s of x1 of s minus b2s x2 of s. So next the second equation was this equation. Now see here, we have to write the equation in terms of x1 and f of s. So we are not going to disturb the equation 1 and we are going to take the equation 2 and we are going to write x2 in terms of x1. So now if we want to write x2 in terms of x1, so x2 is going to be given by this minus b2s into x1 of s is having a negative sign here. If this comes to this side, it will becomes a positive element b2s into x1 of s, and here m2s square plus b2s plus k is multiplying here. When this comes to the another side, it is going to divide. So then what is the term we are going to have? x2 in terms of x1 was this. So now we are going to consider this as an equation 3 and actually this is an equation 1. So now we are going to substitute the equation 3 in equation 1. So now if you substitute it, f of s will be given by m1 s square plus b1 plus b2 into s into x1 of s minus b2s into, we have to replace this x2 with this term. So now if you replace that, so we are going to have b2s x1 of s divided by m2s square plus b2s plus k. So now see, we have to make the x1 terms one side and f of s term, we have to represent the complete the element as x1 of s by f of s. So now we will see how we are going to represent it. So now see, in these two terms x1 of s is common. So now we are going to take x1 of s common from both the elements. So now we can write it as m1 s square plus, and while taking x1 of s as common, so this is dividing here. When we take it as an LCM, it is going to multiply with this term. So we are going to have m1 s square plus b1 plus b2s into x. So we are taking x1 of s common. So next here this has m2 s square plus b2s plus k, minus here b2s, here b2s, both got multiplied, and we are going to have b2s whole square divided by m2 s square plus b2s plus k. This is f of s into x1 of s. So now what we have to do, so we have to bring this f of s this side, then our transfer function was fulfilled. See here, what is our transfer function? x1 of s by f of s. So to fulfill that, we are going to write the equation as, see here, x1 of s divided by f of s, which is going to be given by this, it got reciprocal. So then we are going to have m2s square plus b2s plus k divided by m1 s square plus b1s plus b2 into s into m2s square plus b2s plus k minus b2 square s square. So now this will be our transfer function for the given translational system, for the given problem what they have given us. So for this respective problem, so this will be the solution. What I have written here will be the mathematical model with respect to the x1 of s. Thank you.